So it's a little different when we've got two dimensions, because we have to take into account the vector nature of the forces. We can't just use plus and minuses to consider what the direction, because the direction is more complicated than that. We have angles. So this question is sort of set on a north, south, east, west plane. So we're going to make the x-axis the east-west direction. We can make east positive and west negative. And then the y-axis will be the north-south, with north being positive, south being negative. So the key thing to think about here is the net force is still equal to the first force plus the second force. Okay? So that's still a net force, but we can break this into components. We can then break this into F net in the x is equal to F1x plus F2x, and F net y equals F1y plus F2y. So let's sort of map this out a little bit so that it makes some sense. Let's start with the first force. F1 is like this. It's 150 newtons, and it's at an angle of 30 degrees. So what we can have here is my x and y components. So this becomes F1x, and this becomes F1y. F1x equals, and you have to go back to your right angle trigonometry for this, but you can easily show that F1x, the length of this side, is equal to 150 cosine of 30. And when you do the math on that, you get 130 newtons. And then F1 in the y direction is 150 sine 30, which equals 75 newtons. All right, so that's that. Now I can also do the F2. In that case, that's a little too steep an angle. It looks kind of like this, and the east-west axis is there. I've got 20 degrees here, and the angle itself is 110 newtons. So again, I'm going to draw my F2x, which is equal to 110 cosine 20, and that, when you do the math, equals 103.36 newtons. And here I have my F2y, which equals 110 sine 20, and that equals 37.62. Don't take my word for it. You have to do this yourself, and it has to make sense to you, because if you're just agreeing with me, it's not going to make sense when you kind of try to do this on your own. So that's what we have. Now we want to go back to this equation, and we want to find what the net force is in each of the individual directions. So let's start with F net in the x direction. It equals F1y. So you can see that the x component is the x component is in the positive direction, right? It points this way. And for F2, it's also in the positive direction. So it's going to be, like I said before, F1x plus F2x, which equals 130 plus 103.36, which equals 233.36 newtons. Now, this is a little tricky. F net in the y direction, if we look at the arrows, the direction the arrows pointed, F1y, is pointed up, but F2y is pointed down in the negative direction. So I'm going to actually make this equation F1y minus F2y. And you can see that it's different from that because F2y is down. So we indicate that by making that negative. Okay, so plugging in those numbers, we get 75 newtons minus 37.62. So that works out to 37.38 newtons. So now I have my Fx and Fy. The way I put these back together is I draw another triangle, which shows the total. So the F net x, in the x direction, F net is 233. So that's 233 newtons in the x direction, and 37, it's pretty small in comparison, 37.38 in the y direction. So I've got a resultant. This is then, therefore, my actual net force is in this direction. This is my actual net force. So it's going to be some magnitude at some angle. So that's what we have to figure out now. We can solve this, again, using Pythagoras this time. We can say F net equals the square root of, so it's 233 squared plus, plus 37.38 squared. And then what we get when we do that is about 236 newtons. And then what about the direction? The angle in this case is, I can find it by going tan inverse of, so theta in this case is going to equal tan inverse of the opposite over adjacent, 37.38 divided by 233. Solving all that out, I end up with 15, let's say 16 degrees. So you might want to take an opportunity here to review your right angle trig. The things we used here are cosine is opposite over hypotenuse. Sorry, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. We also use the Pythagoras theorem. We also use tan is opposite over adjacent. So we definitely are taking advantage of SOHCAHTOA. Now, how do I put all this together to give my answer? I would say the net force, is, and the magnitude is 236 newtons, but what direction is it in? This theta represents this, and we know this is east, and we know this is north. So the way I can write this is east, and then I sweep through 16 degrees on my way north. So this is your final answer. The net force is. So you can see that these two people are pulling this crate. Because they're pulling with unequal forces, it's not actually going to go in this straight line. It's going to start to veer 15 degrees north of east as they pull it along, because person one is a little bit stronger than person two. But the net result is this. And that's how you find the net force in this problem.